Hello and welcome back to the next episode in our Factory Builder series. I think we're on about episode 14 now. It seems to be getting very long, but I think the detail that I'm going into, is it too much? Is it too little? You know, that's what I'm aiming at, is that you understand what I'm trying to do. And you can also see the pitfalls that I'm hitting, so that if you hit them yourself, you have a bit of an idea of how to fix them. Now, some of the errors I'm getting are self-inflicted, to say the least. You know, it's so easy to miss connecting up a node, or, you know, just putting a node there in the first place even. But yeah, let's just put it in the comments if you'd like to see more or less, or anything else in particular, or if there's something where yours has gone wrong, if you're following along, and maybe I can go back and help you with it. Again, I'll touch on, would you like me to do some incremental packing up of the actual project files? But I'll have to do that starting from whenever I sort of kind of get the hint that you want that. Because obviously going back now, it's a bit late, because I'm not using any sort of backup or source control on this project, because as it's just a tutorial. Well, it's not really a tutorial, it's kind of more like a code along sort of thing, if you get what I mean. I keep saying tutorial, but it's not. I'm hoping I'm teaching some people some things. Maybe it's just mechanics rather than actually Unreal itself, or maybe you've seen something in here that you haven't seen before, which, you know, just helps you with your game and what you want to do. So without further ado, let's get on with it. We've already just waffled on for a good couple of minutes or so. So we are now going to be detecting collisions. So what I'm going to do first, I'm not going to have anything to collide with. I want to show you a type of collision test. Now, we still need the standard collision test in the tool builder, but we also now possibly need another. So let's just have a look at a different type of collision test. And this is where it's going to sort of continue on. It's not going to go in the base, because I think this is only going to be build tool specific for now. So it is going to be in the tool for the builder. So when we activate the tool, okay, we spawn a new build. Then we do all the tests on the event tick. What we're also going to do here, we're going to, for now, just delink this spawn, so we don't see anything. So now, if I just compile and save that and run it, turn the tool on, which is number 2 at the moment, we shouldn't now be showing. Oh, we are, because we're getting a valid trace. It's still showing visible. Did I just disconnect that? What have I done there? Oh yeah, I've done it too late. Okay, we're going to break it there. That's better. So now we shouldn't see it. See, already hitting problems. I've only just started. So we're going to let's go back into our event tick where all our works are going on. I'll probably put this into a function to tidy it up, but for now let's just leave it there so we can see everything that's going on at once, and then once we're happy with everything, we will put this in a function. So we're not going to bother moving the objects at the moment. What we're going to do is just put a new type of trace in, that will be in a function, but again I'll collapse it down from here. So what we want to do now is something called a box trace, and we're going to do it by channel. Okay, so now we've got a start and an end point, and also a half size. Now the half size is, they call it half size, it's because it's basically a radius. It could have just been called radius, but obviously with a box, radius doesn't mean the same thing, because obviously if you had a perfect radius it'd be a sphere. But if you do it from the centres, it is a radius and it's all equal. And that's what this is going to be. Now, at the moment, I'm not going to do too big a size on this. So we will be using something from the actor, which will be the grid size, to calculate part of this. But for now, I'm just going to show you a 1 meter cube. Well, no, that'd be a 2 meter cube, wouldn't it? So, sorry, 0.5, 0.5, and 0.5. Ooh. Somehow I managed to hit the tab key. Hovering along. There we go. So that'll generate a cube. Well, let me explain it from the start. Right. So what we're going to do now, we're going to generate a line trace. Now, the line trace is going to be just like any. It will be a start point, an end point, but there's a difference here. It's going to have this half size and this orientation. Now, the orientation I'm not going to mess with because I don't need to. But basically, I'll explain what it does. So it says box. So this is a box that it's generating, as I've just explained, half size. So the radius of the box is 0.5. So the complete diameter is 1 meter, 1 meter cubed. Yeah. So it's going to project a box from here to here, this size, and at these rotations. So you could do it at an angle if it's meant to be going through an angle. You could put some sort of degrees on there. Now this one I'm going to leave as visibility because we're not tracing the ground. We're going to be tracing for any object that might be sat in the way. So now some of you know how this works, I would guess, and some of you might not know. So let's just show you how this works. So we're going to need a start point. That is all calculated in this grid. We may need to actually change how this grid is calculated now, because we're going to need an additional value. And that additional value is going to be the beginning of the box. So if I bring up the whiteboard from before, right, so now we need to now test the grid we're landing in, but we also need to know how large the item is we're landing in. But that's simple enough because we created that grid size variable, didn't we, in our generator, and that will be in all objects that we create. We're going to have this grid size. So this is going to take up a 1 by 2 grid, but we're going by 2 by 1 because of the way it was built. So it's going to be 2 long and 1 wide, yeah? And that there will depict how many of these boxes it's going to take. So if we place the box here, yeah, and its front is here, it's going to take up both of these squares. As we haven't done any rotation yet, which we will cover probably in the next lesson, we're going to just automatically just choose the same orientation, so the box behind it, yeah? So if we aim in this box, it'll be these 2 boxes for the generator. It could be a 4 grid size item, you know, if it's a larger building or something. It could be a 9, could take all of these up. So what we need to do now is test every single box that these things overlap. So we're going to now aim for this spot and we get this here. But what we want is this point here, yeah? And it's going to have to be the middle, but at the extent. So the extent of this box will be it won't be 199, it'll be 149, but I think we're going to be 150 at the moment because it's easy to calculate, isn't it, for when we round up. So it'll be 150 by 199 because we don't want to go into this box, which is starting at 200 there, yeah? We only want to start at the beginning of this. So we need to add 99 to this number, and then we need to get half the width of a box, which is 50, and add it to our 100, just like we was doing with the other grid position. But now we've got the start point. Then we need to calculate the end point. Now the end point is going to have the same middle value. So whatever this middle value is, which we settled on 150, didn't we? We then need to drag that up to here. Now this is 0, isn't it? So that'll be 150, 199 to 150, 0. Understand me? So this number is the first one, the x. So we always choose x first, and then we do y. Yeah. So this extent is 100 across, half of it on top, 150. And then from there, we need to measure back to the end point. So it's 100 there plus the 50 to get to the middle. Yeah. So it's halfway between the 200 and the 100. And then that figure is 0 because that's the starting point. Obviously, it'll be different in the game because, yeah, there'll be infinite amount of grids. But in this instance, on this example, this point here will be 150, 0, because it's at the 0 plane there. Okay, so we're back in our tool, our building tool. So we have this position we need to calculate. So for now, we're just going to put it in here. I will possibly create something in this attached to grid, maybe, to bring all these functions out, tidy it up later on. But for now, let's just make it here, and we'll worry about tidying it up afterwards. So first thing we want to do is we want to see what we're doing. So we're going to turn our visibility trace on, our debug trace on. So if I get debug style, was it trace, get debug draw trace, and put that into there. And what else are we going to look for? The duration. Now the draw time is going to be, in fact, it doesn't really make that much difference. It's going to be firing every frame. So what we're going to do, we're going to change the trace color just so we can see what's going on, and we're going to have like a blue color. Actually, that will do. That will do. It seems nice enough. So we can see this trace is different. Yeah, like I said, so we're going to use the visibility trace. Now, actors to ignore is an array of actors that you don't want to collide with. Now, we don't want to collide with the ground as such. But at the moment, I'm going to ignore that because our ground's flat. And if we do our trace correctly, it should trace perfectly and not show anything that we don't want to. So anyway, let's get back to it. So we now have a start point and an end point. We know where those are. Now, we've calculated those. Well, we've part calculated those from this attached to grid. So we've got our X and we've got our Y. But that X and Y is bang in the center, isn't it? So we're going to calculate a new set of values to plug into here. So we're going to get our location and we're going to divide it by, oh, I really probably should have just break that, shouldn't I? Yeah, let's divide this by 100 and 100. Okay, so that divides it. That gives us our base value. And then we round it down, don't we? So we then floor. Now it's going to have to be for floor float. Obviously that won't work, so we're going to need to split that structure in as well. And we want to do the X. And just duplicate that. And we want to do the Y. Okay. And then we want to just bring those in, multiply both of these, which I could have done as a vector, but like I've done here, but it doesn't matter now. But I still got to rebuild vector anyway, and then times it again by 100. Now that gives us our other value that we had before. So now we have our corner value just like before, this one here. So if we're taking this red trace, it'll be this one here. If we're taking the blue trace, it'll be that one there. Yeah. So, but our start is centered, and it's also on this back extent here rather than the front extent, which is easily gotten because we know our grid size is 100 Unreal units because it's 1 meter, because we're using 1 meter. So simple bit of maths, and we've got to remember that this is zero based, so we don't want to overflow into the next box. So what we want to do is add on to the X value. That's what we're going to do at the moment because of because we're not yet checking orientation. We will have to change it for orientation depending on which way we've rotated it, but we need the X value. Yeah, so what we need to do is add. Why does it, oh, context sensitive was off, wasn't it? Add, and we're just going to add 99. Okay, the Y value we need only half. Now I'm going to try it with 49, so let's just do an add. Let's try that one, and we're going to try it with 49 and see if it gives us any strange values. Right, 49. Okay. Now we don't have to specify the size of this box that we're making. We just need to specify the start and the end. So now let's drag this along. I hope you understand this at the moment. So what we've done, the usual, divide by 100, rounded it down to get our whole value. Yeah. And then we times it by 100 again to get this corner of our box here, this top left corner, just like we did in the last episode. But then we've added 99 onto the X value so that we can find this edge rather than this edge. So we're now down here, and then we've done the Y across to here. So we should be at this point right here. Okay. So we now have a start point. What we need to do now is remake that as a vector. Make vector. There's X, there's Y. Well, that's an int vector. I don't want an int vector. Let's do that without attaching it to there. We just want a standard make vector. There we go. Not an int vector. Let this translate it itself. When I hook these in, it will automatically translate. See? Just makes it a little bit easier. And our Z, remember, comes from here. So we'll bring that in there. And we need to make sure that we divide that by 1 so that we don't change the Z value. Divide by 0. Not sure if it'll throw up an arrow, which it probably would. That's probably why you use safe divide there. But if I divide by 1, it'll give them the same value that came in. Yeah, 100 divided by 1 person, they get 100. Yeah. So we now have a start point. So that will go in there. Now we need an end point. In fact, what I'm going to do, I'm going to 0 this half size out so you can see what happens. Yeah. Okay. So now we need to find our endpoint. Now our endpoint is going to be along the x-axis only. So what we need to do is use the same y value, the same z value, and we want to modify the X. Yeah. Now, for the X value, we need to know the length of the object. So we need to bring our actor in, and we're going to validate get it. Okay, and I'm going to throw him in there. So you go there, and oops, you go there. There we go. So now we have our actor. Let's again move this over. This is why I use functions, because it gets a bit messy sometimes. So if our actor is valid, yeah, then we're going to perform this. If it's not, we're not going to bother performing it because we haven't got an actor. So there's an issue somewhere. But it should never fail because it should be set, because our code is correct. But cover all bases. So what we want to do now is get grid size. And then what we want to do is we want to split the struct pin. Oh, this, right, we are going to modify the Y as well, because we need, just in case it's a wider object, so we might as well do it now. So what we want to do is break this vector again. We still need to build it for here, so we'll leave that one there. We'll just re-break it, and we're going to now find the rear of the object, and we do that by multiplying this number and adding it to this one, if you get what I mean. So this one will have to be multiply by 100. Oh, can't just multiply by 100, you have to get a multiply node, and we'll duplicate that. In fact, no, let's delete that. Let's change the value first, and then we'll duplicate it. 100 and 100. How did I add that in? Did I accidentally hit add pin? Remove pin. There we go. And then we'll duplicate that. So that's another multiplied by 100. Okay, and then we add these two values together. So again, let's move this over further. So we're not so bothered about the Z. The Z, we'll leave as it is for now. We may have to modify that to bring it up off the floor, but a few checks we need to do there. So let's come across and go to add. So we're going to add the X and the X there. Oop, that missed. The X and the X. And then the Y and the Y extents. Right. Is that right for the Y? No, the Y doesn't change. The Y doesn't change. See, I'm getting confused here. The Y doesn't change. But what the Y will do is it will modify this here. And you'll see why in a minute. But for now, we won't change that. So the Y will be fine. So now all I need is to create a new vector. Oh, let's make vector. Get it right. Okay. So the Y hasn't changed because we still want it halfway across. So it's not, that's not changed. The only thing we want is back, which is the rear of the object, which is X, and the Z hasn't changed. So that will be our end. Right. So now this should be just drawing a trace for us. So apply and 2. As you can see, all it's doing, the start point is perfect. Actually, it's one block behind, isn't it? Are we one block out again? Or is that the actual... Ah, that's the hit. That's the hit, sorry. Okay, it's getting a hit. So it's drawing a line, and it's getting a hit. So let's now add in and try and visualize this properly. Our box. So like we said, box is going to be a meter back. But what we want is to get the grid size for whether this is wider or not. So let's get the grid size, and we're going to sorry, not add, we're going to multiply by 0.5. So if it's 1, it'll be half, so it'll still be a meter wide. And we plug that, so we need to split this here, split struct pin into there. And at the moment, we're just going to put this, again, a meter as well. Yeah? Compile and save that. So now what we've got is, whatever the Y grid size is, it will times it by 0.5 to give us the proper diameter of the width of the object. Hope I'm not overcomplicating this for you, so I will go through it again as we check it, but let's just have a test. Turn on number 2. Right, we're not getting a box. I do see 2 lines there, but I don't actually see a box. We're going to make this rather large, this box now, just to see what size it is. Oh, 0.5. Ah, I'm supposed to be using units, aren't I? Okay, let's do this by 50 units. This would be 50 units, and this would be 50 units. Maybe that might help. I was thinking scale, I guess. Must have been. Let's press number 2. Okay, there we have our box. Now the extents are being drawn, and you can see that it's actually going way too far. That's what those blue lines going into the distance are. And it does look like I need the center point as well. It's not actually starting the edge of the box, it's starting the center of the box there. So I do need the actual center. So we can use the original center. But as you can see, that's going very, very far into the distance. I need to have a look at why we have done that. Or I have done that. And we've multiplied it by 100. Why did we multiply it by 100? Am I multiplying the wrong way? I think this should be multiplied by 100, shouldn't it? And then that, possibly that way around. Swap the so multiply the grid size by 100 to get the number of units, and then add that to the original X value. So we don't need this part here. Well, sorry, we don't need the 99 here. So I'm just going to bring that in to there. So we're starting at times that, and maybe add 49 to that one, and bring that over there and that over there. A little bit messy. Oh, it's not 419 either. 49. Let's figure out why this startup trace isn't working properly. There we go. Started. Perfect. So we know that value there is the grid size is 2. So I'm going to rewrite the grid size bit. Okay, so we have a start value. That's working fine. We then break it and we add the grid size times 100. So that would be 2, but the first one is already a box. We need to remove the first box that the trace draws, because it's already drawing a 1 meter cube, regardless of how far we're going. So this is correct, but we need to subtract 100. As I say, the reason is, let's zoom out a bit. Let's make this a little bit more viewable. It's not going to be great with all these green lines going everywhere, but once it's done, it's done. So that is what goes in there now. Let's make this a little bit neater so we can see this. So bring that across to there. That'll do. Just notch it down the keyboard. So yeah, we're subtracting 100 now because our first cube is already 100. It's already, so we can detect a minimum of a cube to start with without putting any of this into it. So if this is 200, we minus 100 because we only want to move 100 more back. Do you understand me? And I'll show you that now. It should work. So there we go. And as you can see, it's getting a hit. Now that's the first point of contact when the box is drawn, and it's hitting the ground. But we don't want it to hit the ground. And as you can see, it's halfway through it. And that's because we haven't set the Z value. The Z value is always going to be the height of the floor. So we're going to add 49 and hope that 49 clears the floor. So the Z value itself is actually going to come out, and we're going to add at this point, probably here. So let's press the Alt key there, and we'll bring this out, and we will add, and we're going to hope and pray that this 49 value is correct. It should be, because it's 0 based, so we don't need it at 50, we need it at 49 because we're including the 0 as well on the 100. But let's see if this actually collides. But it's still colliding with the ground. Okay, so maybe it has to be 50 then. So if that's the case, I will also change anywhere. Oh, I did anyway on this one, didn't I? And we will just go with the 50, as it seems that is the way it has to go. Although it still says it's going to collide. But as you can see, it is working. And the red is where it's colliding with the existing collider before it disappears. If I change the time down to something really stupid like 0.01, yeah, we might not see that happen. It might still. Yeah, it's still doing it, but the trace is still showing. So there we go. We're still kind of colliding with the ground, but we suppose we could bring that up again just by 1 unit. We could also put the ground in as not colliding, but it depends on our terrain. I think this might be useful about our terrain because we detect bumps. There we go. So it's red because it's not colliding with anything. Yeah, there's no hits anywhere. But now we have a collision test. What we're going to also do is hook back up our actor. So we're doing the test. So don't worry about doing this yourself because this is all got to get tidied up now. It's all got to be put into one. So I'm just going to hook that back up so it moves our box like it did before. But we'll probably get collision tests now. No, it's not getting a hit because we haven't set collision on. Right. Okay, that makes sense. Now we get a hit. See where it's blue? We get a hit, which is perfect because now we can detect what's underneath. So at the moment, see how we've got the blue and the red? Because the blue is actually hitting. Yeah. So what we're going to do is let's actually put that into the tool before we start tidying up so we can see it. So if the set actor hidden in game to none, we can base that on we're not going to base it on whether this is a valid hit. We need to do that up here and just use a trace. This is now going to be our valid return value here. And so if I bring this out to there and see if that will work. And as you can see, oh, Why is that showing there? I can't put... Okay, it's backwards, so they're not. It's not a knot. It's just a straightforward. So this is so messy, and it's a little bit... Because I'm doing this on the fly here. I have done things like this before. But every time you do it, everything's different. It always is. I don't know why. So, there we go. Can you see we haven't got a... Can you see? It won't let me put it now. But I can still place it, unfortunately. But we're getting a hit there. Although it's not letting me place it. Oh, yes, it is. But for some reason, it's not showing it. So, we need to remove the click part now when this is also invalid. But now we can no longer place things when... Well, we can place them. But it's, as you can see, the visibility isn't shown because we're not allowed to place things because we're overlapping. Yeah, but as you can see over here, I have been placing them, but because the code doesn't run because I've told it not to, then it doesn't add it in. Oh, it doesn't show it, but so it doesn't go to visible when we place it. We can just prove that by when we do our click action start, we set this actor to hidden in game to false, and it will appear, and we'll just prove that it is actually going in there. So what we need to do now, we need to be able to catch that in here as well. So let's just prove that works. As I said, that it is still failing as such. So if I place that, see, I can click still and place it, even though it's overlapping, it's not showing it because I haven't told it in the place method that it's valid. But that's simple. Let's keep track of that in our variables. So we could put valid placement and be valid placement, and it is a boolean. That's what we want. We don't need to put it on show, we don't need to set it on spawn or anything like that, because what we're going to do is we're going to set that here. Oop, I wasn't close enough to get the set deal, was I? So bring that to there, the valid hit to there, and bring this one back to there. And then let's just remove this not because we're no longer using it. We're not using it. We might as well just drag this valid placement in there. Okay. And let's just test that that is still working. Yeah, it's still giving us our correct trace. And now all we need to do now is put that into our placement, which is in action start. There we go. That's the thing then. So when we want to place, we don't just want to run it, we want to check. So if we branch, okay, on this condition, and we want to do it on false, yeah, because false is a valid hit. Okay, so a false is valid placement, means there's no collision, yeah, because we're setting it to the value of the collision. So if it's false, that means there's no collision. We can add the object. I had to think that when I was talking about it. So if I place that, and as you can see, perfect, but I can't place another one overlapping. I click to my heart's content, but I can't because it's blue. Perfect. It's doing exactly what it says on the tin. There we go. As you can see, I'm clicking like crazy, but no new generators are appearing. Now, I don't see any. So I have one generator. Yeah. Placed. and then undo that. Yeah. Oh, sorry. Yeah, there's one on the tool. If I right click, it will go. Yeah, it's okay. I was just wondering why there was one extra, but that's because when you right click, it's gone. So now we have a valid placement, but there is one problem with valid placement like this at the moment and the way it all works, and that's because of rotation. So now we have to work out the orientation of the object. Once we've worked out the orientation of the object, then we can work out which direction we're checking for our traces, because otherwise we're going to be checking in the wrong direction if this is rotated 90 degrees. So all that code we've just done is no longer going to work. But not, well, it will work, but it needs some modification. But that's not a problem. We've got a working concept. All that's just working concept. All this now is most likely going to be changed, but we've got our base to work from. We know how to find when and where we're going to place things. Okay, so hopefully now you understand what that was. I'm just going to go through it again. So we get our initial hit onto the ground so that we can get our coordinates. The reason we hit the ground is to get our coordinates. If we hit an object, then we'd have to get the object, then we'd have to get its coordinates and work out where its center is, all that. Forget that. Let's just hit the ground and find our coordinates. So we divide by 100 only on the x and y because we're not checking the z. So we just divide that by 1 to keep it as it is. So we divide it by 100 so that we can then round it down using the floor to get a whole number, which is then re-multiplied by 100 to get our corner position here. Yeah. Just like in the other one. Then we're adding 49. It's weird how that works at 49. Right, I'm going to change those to 50. The only reason the x, so right, change those to 50. We're keeping that as 51 because we want it slightly above the ground so it doesn't go through the ground. So we add 50. Because we want to find the center point. So it's the exact same calculation as what's going on here. So I could have just dragged those in, but I want to amalgamate both of these because they're both going to work in tandem. Yeah. Okay. This value that we get here, we then just pass instead of these to here. Do you get what I mean? So divide by 100. Round it down, times by 100 to give us the top left hand corner. Then we've added 50 to find the center of our cube. So we add 50 and 50. We've got our center. Okay. Then we rebuild the vector, and that's our start point for this trace because the cube is 50 diameter, so it's a meter square. Yeah. We have to start from the center of the square because the cube automatically fills the whole square. Then all we do is get the grid sizes from the actor. At the moment, we're only messing about with the grid size of the X. We will need to do the grid size of the Y as well. But the grid size of the X is different. So we need to times the grid size by 100. So if it's 2, we times it by 100. Yeah, and we then deduct 100 because otherwise you have an extra block because this is already a meter square, so we need to deduct the size of this. So if I set this just to the grid size on this X, let me just break this pen and let's just see that what happens if that is just 0. What happens? Because obviously, if it's times by 1, if it's x is 1, it's going to minus 100, so it's going to be 0. So we hit 2. And as you can see, oh, it does have a little bit of a bug, doesn't it? It's drawing it from the wrong place. Okay. Is that because of the start position and the end position? So it's the end position I really need to modify. So we'll put that back in there. And it's the end position I'm modifying. So it's the start that's playing up here, is it? Did I change the start? Or is it the end? Let's have a look. No, it's definitely the end that's playing up. So we're starting at... We should be starting at the front. And we're going to the back. So why? This is interesting. Because obviously if this is only 1 times 100 minus 100... It's giving us a different location for the start. Okay, this shouldn't be... Sorry, for the end. So the end is going back the opposite way. Let's break that again. Leave it at 0. It should only be drawing 1. Yeah, that's the problem. For some reason, it's drawing 2. I don't know why. So that will need to be checked, because if there's only a meter square object, which something like a lamp would be, we only want the 1 box. But for some reason, it's extending itself past itself. So I wonder if this has to be at least... 1, so that it doesn't 0. So might have to do a compare on that value if that's the case. Yes, it has to be a minimum of 1. That's fine. We can fix that. So we now know that. So we bring that in here. And once we've minus 100, so we could just minus 99. Let's try that. Let's try that. If we do that as 0, oh, it's because we're minusing the 100, aren't we? So that will be 100, won't it? We're plugging 200 in there. That's what I should have done. Let's try that. I'm doing negative values by minus 100. That was my fault. That was a stupid one, wasn't it? But for some reason it is doing a rather large cast. So let's have a look. Times in 0 by 100, then minus in 100. So what we'll do is we'll leave that plugged in there. We'll break this one, and we'll just say that that was 100 coming through because it's 1 times 100. Yeah, just make sure this works. And test number 2. There we go. Perfect. Yeah, that's what it was. Simple little mistake. Little bit of mistake. Just plugging the wrong value in. So yeah, so now we're only checking the 1 square grid. Right, we're going to leave it there because again, it's getting near the hour mark on the recording. So hopefully edited down, this is going to be less than 45 minutes, but we shall see. I'll try my best. But anyway, I hope you get an understanding of what was going on there, and you should be able to now have a test box to figure out where our placement is, and it now works. We can't keep placing. I'll keep trying. It's there, not there. Cancel the tool. We've still only got 1 yet. Then we put the tool on. We can't put it there, but we can't put it there either. Okay, so it's hitting that box. Okay, is that a good thing? Let's have a look at how close this is drawing. It's bang in the middle, but it's extending past. It is going past, isn't it? Oh no, it's not. Is it? Trying to say. Anyway, we'll end it there. We'll have a look at that another time. It's, to be honest, we probably wouldn't want to place another object there. It's too close anyway. Maybe that's a good thing, so you leave a small gap between objects. I don't know. Maybe our placement of our actual object is slightly wrong, because we're using 50s now, and that was 49s. So did I use 49s anywhere in this? You can switch off now if you want to. I am supposed to be going. I'm just going to quickly just debug this attached to grid. But no, we are using 50s. So Okay. Never mind. We will look into that. We could maybe just deduct one off the trace or something stupid like that. Yeah, we could just deduct one from the trace and then we'll go from there on the X. So if we just put subtract and then plug that into there and just subtract one at the end of it and just see if that works. And if it doesn't, we're going to leave it there anyway. So there, yeah, just one can fix that. So I will allow that. It's up to the player that they control what they're doing, not up to me. As you notice, it doesn't collide with the box while it's there because we haven't turned the collisions on. So we turn them on afterwards, don't we? So yeah, it doesn't detect itself, which is good, but it does detect other things. So there we go. Collisions are working, and we can now place objects without them overlapping, and that's a good thing. So we're going to work on rotation next, which is probably going to destroy all that collision code. So we'll see you in the next episode. Take care.